Hello friends, today we will discuss about some important concepts of C# programming. We will discuss today about indexing and arrays. So here is the list. What is indexing in arrays in C#? What is one-dimensional array? What is an array? What is an integer of an array with example? So let's begin. First one topic we have indexing in arrays. So what is an indexing in arrays? Indexing is the way of accessing individual elements of an array using their position index. So if we want to access any individual array one by one, then we can access it through indexing. As I already told you, indexing always starts from 0, 0, 1, 2, 3 and so on. How many elements we added, then we can access it through the indexing. Indexing position means starting from 0 to 10, means how many elements we added, we can set that size and then we can access it through the indexing position. In C#, array indexing starts from 0. As I already told you, indexing always starts from 0. The first element is at index 0, the second is at index 1 and so on. As I already told you, indexing starts from 0 and then next element 1 and then next element at 2 and so on, like that. It's a usage of indexing. It uses square brackets with an array name. If we want to use the indexing, we have to use these indexing square brackets with that array name. So here is the example. This is the array name and indexing. We have to use it with the square brackets. So how to declare it? You don't separately declare indexing. It's inbuilt into arrays. We do not want to use the indexing separately, or we do not want to declare indexing separately. Instead of arrays, we can directly use it with the arrays. It is inbuilt into arrays. When you declare an array, you can directly access its elements with indexing. If we want to declare an array, we can directly access its elements through the indexing with the indexing position, means starting from 0 to 10. As many elements we added, we can set that size, and with the position of the index, with the position of the elements, we can access it through the indexing value, indexing number. So here is the syntax of indexing: array name and then square brackets indexing. Its flow diagram is as below. So here is the indexing and here are the values. We added 5 values from 10 to 50. Okay, so this is the total length, means 5 length of elements we added into an array. And here is the indexing start from 0 to 4, not 0 to 5, only 0 to 4, because total length is 5 and indexing starts from 0 to 4. So this is the concept of indexing. Next we have a 1D array, means one-dimensional array. So what is one-dimensional array? A one-dimensional array is a simple single row or line collection of elements of the same data type stored in contiguous memory location. So 1D array is a simple, like if we want to add arrays in a single row, then we can go with the one-dimensional array. But here is the thing, we have to use the same data type. As if we declare integer data type in a one-dimensional array, then we have to go with the integer, not with the string. If we declare the array with the integer type and we are adding the value of the string type, then it will give us compile time error. And it stores the data in contiguous memory locations. So what is this? When you create a 1D array, all its elements are stored side by side in memory without gaps. This ensures fast access because the memory address of any element can be calculated directly. So if we want to add the elements into an array, so this is the memory locations. In contiguous memory location we can add without any gaps, we can add the elements, and one after other it will add the array values one by one into an integer type of array or any string type of array. What we are declaring, according to that elements we can add, and we can access that elements through the indexing position. It is like a list of elements arranged one after another. So as I already told you, it is like a list of elements which is added into an sequence into an array, one-dimensional array. So here we have the syntax of one-dimensional array. First we have to set the data type, means integer, string or any list type we have, and then square brackets for indexing, and then array name which we provide to that array, and we then initialize, means allocate memory to that array. with the new keyword, and then data type means integer type or any string data type we can set here. And here is the thing, we have to set the size, means how many elements we want to add into this integer type of elements. Then we have to set this size, means 10, 15, 20, as per a requirement we can set the size of this one dimensional array. So here is the example of integer type. First we declare the integer type elements and we set the size here 5, and then we added 5 values, 5 elements into an integer value. But we started from 0 to 4 index, not 0 to 5, as if we set the size here 5, but we are adding 6th element into this integer value of array, then it will display an exception. And if we want to display these these elements, then we can use for loop, for each loop, for displaying that array. Here we have one real world example. Think of a row of lockers in a school corridor. Suppose there are some lockers in a school corridor and we want to access that lockers. So how we can access it? If we are considering that is a array of elements, then how we can use it? Each locker we can consider it as a one array of element, and one locker number we can consider it as a index, one index. One locker means one index. An item stored is equal to one value. We can store one value in that one item. So here is the thing, one locker means one array, locker number is equal to one index, item stored is equal to one value. So this is a example of one dimensional array. Now we can look this one into Visual Studio. Here we can see one dimensional array. First we have to write the data type and square brackets for an array. Then we can give some number array for this integer of arrays. Then we can initialize it, means allocate some memory to that integer of arrays. Suppose we want to add 5 elements only. Now we can add elements one by one with the indexing, start from 0 to 4. Here we can change the indexing from 0 to 4. Now we can change the value here. Then we can use for each loop or for loop. Right line, integer array, and then one by one it will display the list. So here we have the list which we are added, means 5 elements we added to that integer of arrays 55, 100, 88, 64, 11. It added the values in a sequence one by one, one after other. So in this way we can add the elements in a row with the indexing, but indexing start from 0. This is the main rule of indexing, means it always start from 0 to 4. As many elements as we have, according to that we can increase the size. But here is the thing, we have to set the size first, means allocate some memory for this one. One more thing, if we do not want to initialize it first, after some time we need to initialize it, means allocate memory after some time, then we can do it in this way. So in this way we can initialize this value after declaration, not at the time of declaration. In this way we can use. Suppose here we declare only, set the size only 5, means 5 elements we can add, and if we want to add 6th element, then how it will react to this situation. Now it is giving us an exception, So if we are want to try or to add values as greater than the allocated memory, then it will give us an error. So only that much of elements we can add which we initialize it earlier, means which we initialize the elements of means size of the elements, that only elements we can add to that list. So this is the integer of arrays, one dimensional arrays. Next we have array. An array is a collection of elements of the same data type stored in contiguous memory locations. An array is a collection of elements, means we can add as many elements we want to add, but here is the thing that should have same data type. Means if we declare the integer of arrays, then we only can add integer of arrays, not the string of arrays, and we can add it into the contiguous memory locations, mean one after the another it will add the data in a sequence. So here we have the example. In this way we can also allocate the elements to that integer of arrays without declaring the size of that integer of arrays. Next we have array signature. The signature of array specifies its data type and rank dimensions 1D array. So the signature of arrays is like its data type and rank dimension, means what kind of arrays we are using, means we are using one dimensional array, two dimensional array, three dimensional array, or jagged arrays. Here we are using only one dimensional array. So this is the syntax or signature of one dimensional array: integer, square brackets, then array name. So this is the array signature, data type and 1D array. Here is the example of this one. Next, declaration, how to declare it. We can declare an array, means reserving a reference for it without allocating memory. As I already told you or shown you in that example, we can first declare that integer of arrays or any string of arrays. Then after that where we require that initialization of elements, or if we want to allocate some memory to that array, then we can initialize it after that declaring the array. So this is the only declaration part. After declaration, if we define an array, means allocating memory for it after declaration, means after declaration we need to add or allocate the memory size for that particular array. Then we can do it in this way. First we declare this, and after some time where we need it, then only we can initialize the values, means we allocate the memory size for to that integer of arrays. So this is the syntax of this one: data type square brackets array name is equal to allocating memory with a new keyword, and then data type and then the size of that array. Next we have integer array. An integer array is an array that stores multiple integer values in the contiguous memory locations. An integer array is like if we want to store multiple integer values, then we can do it, but we have to declare that array with integer type, means integer data type. Then only we can add that values into an integer. If we declare it as string value, then we can add string type values. It totally depends on the requirements, and we can add the values in contiguous memory location, means one after another and in a sequence format. It allows us to store a fixed size sequence of numbers instead of creating multiple variables. We can set the size for that particular array instead of if we do not want to create multiple variables for that, then we can go with integer of arrays, where we can add multiple values, as many values as we want to add into an array. Here is the thing, here we can add directly without set the size of that integer array. We are directly providing the elements to that integer of arrays. Now let's see the string of arrays. As we already saw this one, integer of array, now we can go with the string of arrays. Display values. If we want to directly assign some values, then we can do it in this way. And then developers. So we add the elements on the declaration time. And now if we want to display these elements, we can use a for each loop or for loop as per our requirement. Here we have to set the data type, and this one. Now let's see what it will provide us. Now it is giving us the elements, 4 elements according to the indexing, means 0 1 2 3 4, 0 2 3. It displays us the values in a sequence. Suppose if we want to declare the size of this one, then on the declaration time we can set the size as it is, like this. And if we do not want to set the size on the time of declaration, then we can do it after some time where we need it, then only we can go with this. Here we allocate the memory after this for each loop, where we want to use this one, where we need it to declare the values, or where we want to allocate the memory to that array, then only we can do in this way. Otherwise we can go initialize the values along on the declaration time, or in this way we can directly assign the values without writing any memory allocation size. So this is a one dimensional array with string of arrays. Next we have today's summary. Now let's revise what we learned today. First one is indexing. Accessing or modifying array elements using their position number starting from 0. So indexing concept always starts from 0. If we want to add elements into an array, then we can go with the indexing part, means 0 to elements, 0 to 1, 0 to 10, 0 to 5, like that. As many elements we can use, or we can add with the indexing. Next one is a one dimensional array, a linear collection of same data type elements accessed with a single index. If we want to use a one dimensional array, I showed you that example also with integer and string as per the requirements. But here is the thing, we have to use the same data type, same elements of data type. If we are declaring integer type of elements, then we can only add that integer elements, not the string one, and it will consume that one index as per element. Next one is array, a collection of elements of the same data type stored in a contiguous memory locations. So array is like it stores the elements one after another in a sequence, proper sequence it will follow in an array with the indexing. Indexing is inbuilt with the array. We do not write or declare the indexing separately of the arrays. We can directly use it with arrays. Integer of arrays or string of arrays. An array specifically used to store multiple integer values or string values in a sequence. So if we want to use that integer or string array, then we can go with that, and with that same data type of declaration we only add that same data type values, not the different data type values. Otherwise it will give us compile time error, and it also add the values in a proper sequence one after another. So these are the concepts of indexing and arrays along with the one dimensional array. You can try these examples in your Visual Studio. If you have any doubts related with these topics, you can mention them into the comment section. Let's wind up today's session. Thanks. See you in the next lecture.